Are Donut Labs' battery tests actually designed to mislead you into a false sense of security? They have recently made waves by showcasing their battery cells surviving external heat tests of approximately 100 degrees Celsius to demonstrate stability. However, if the most catastrophic thermal reactions in lithium-ion chemistry typically don't even begin until the internal temperature hits 200 degrees Celsius, then what exactly is a 100 degrees Celsius test proving? Let's find out in today's episode. Donut Lab has been vocal about their unprecedented safety margins, using promotional videos to show their cells under thermal stress without ignition. They present these thermal tests as a definitive benchmark for stability, suggesting that because the cell doesn't vent or explode at these temperatures, it is inherently safer than the competition. They lean heavily into the visual narrative of, "Look, no fire," effectively using the 100 degrees Celsius mark as a psychological anchor for safety. But we have to ask the hard question: do these controlled, low-temperature demonstrations actually reflect the violent, high-pressure environments of a real-world electric vehicle battery pack? In a modern EV, batteries aren't just sitting on a lab bench. They are packed tightly, under high state-of-charge levels, and subjected to rapid discharge cycles that generate immense internal heat. By choosing 100 degrees Celsius as their torture test, Donut Lab might be cherry-picking a temperature that sounds high to a human, but is relatively comfortable for a lithium cell. To understand why this matters, we have to look at the missing context: how lithium batteries actually fail. The dreaded phenomenon known as thermal runaway is not a single event, but a cascading chain reaction. It begins with the decomposition of the solid electrolyte interface layer, which typically occurs between 70 degrees Celsius and 120 degrees Celsius. This is a manageable stage of degradation. The real danger, the point of no return, happens much higher, at approximately 130 degrees Celsius to 150 degrees Celsius. The separator between the anode and cathode begins to melt, leading to internal short circuits. However, the explosive runaway, where the battery generates its own oxygen and becomes a self-sustaining fire, usually requires temperatures up to 220 degrees Celsius. Research from the Journal of the Electrochemical Society indicates that peak heat release rates often don't occur until the cell reaches 210 degrees Celsius. By stopping their torture test early, Donut Lab is effectively avoiding the temperature range where the actual chemistry of a lithium battery is put to the test. Does real battery data suggest that lithium cells survive far above basic heat tests? Absolutely. Scientific literature and industry benchmarks show that standard lithium-ion cells are much harder than Donut Lab's marketing suggests. Many high-quality nickel-manganese-cobalt, or LFP cells, are designed to withstand operating high temperatures for thousands of cycles with only moderate degradation. In safety hotbox tests, standard automotive-grade cells are frequently required to withstand 130 degrees Celsius for up to an hour without catching fire to meet basic certification. Therefore, surviving a simple boiling point test isn't a breakthrough. It is a baseline expectation for any battery that isn't fundamentally broken. When we compare Donut Lab's extreme demonstration to the standards, which involve crushing, overcharging, and extreme thermal abuse, the threshold they use appears remarkably tame. It's a classic case of setting a low bar and cheering when you jump over it. This leads us to a troubling conclusion. The deception lies in the psychological gap between uncomfortably hot and chemically unstable. To a human, the heat used in these videos is painful and significant. To a battery's internal chemistry, that same heat is just a bad day at the office, not a death sentence. By publicizing a test at this specific, lower temperature, a company can create a halo effect of safety. You can see the steam, the digital readout, and instinctively believe the battery is fireproof. It is a simulation that intentionally omits the very variables that cause EVs to burn on the highway. It gives the impression of safety without the substance of a stress test. What are the critical details that Donut Lab did not show you? Transparency is the enemy of a misleading test. In their demonstrations, several vital engineering factors are conspicuously absent. First, what was the state of charge of the battery? A battery at 10% charge is inherently more stable than one at 100%. Thermal runaway is far more violent and occurs at lower temperatures when a cell is fully charged. Second, what was the internal pressure of the cell? Safety is often determined by how a cell vents gas. if they don't show the pressure buildup. It isn't showing the risk. Furthermore, they omit the propagation factor, how heat moves from one cell to the next. In an EV pack, one cell reaching a high temperature might be fine, but if it triggers its neighbor, the whole pack goes. Donut Lab focuses on a single, isolated cell under mild stress, ignoring the complex, high-pressure reality of a multi-cell power system. How are real battery safety tests actually done by professionals? Genuine industry leaders don't just put a battery in a warm oven. They perform nail penetration tests, where a steel spike is driven through the cell to create an instantaneous internal short circuit, forcing the battery to handle its own energy release. They conduct overcharge tests, pushing voltage far beyond limits to see if the internal chemistry can stabilize itself. Most importantly, they perform thermal abuse tests, where temperatures are pushed well beyond 200 degrees Celsius to find the exact temperature where self-heating begins. These rigorous protocols are designed to find the breaking point, whereas Donut Lab's tests seem designed to avoid it. Ultimately, safety isn't defined by what happens when things are slightly uncomfortable. It's defined by what happens when things go horribly wrong. By showcasing stability at such a low thermal ceiling, Donut Lab is providing an answer to a question no one in the industry is asking. If we want to move toward a truly safe green energy future, we must demand data that reflects the actual thermal limits of lithium chemistry. Don't be fooled by the steam and the selective sensors. The real truth about battery safety only starts to emerge when the temperature climbs much higher, into the dangerous territory that Donut Lab is seemingly afraid to explore.